Hey everybody, this is Larry. This is day 8 of the November Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, binary tree tilt. Given a routine, return to some, what is the tilt? Tilt. Okay. Okay. So n is 10 to the 4th, so the naive solution is going to be n squared. And that's gonna be too slow. So we want to do it in linear time. It's just depth first search and just keeping track of things, what I call bookkeeping. And I think that's pretty much all you need to go, which is try to figure out the recurrence. And with binary tree and these kind of problems, you could sometimes do it with breadth first search type things, with a queue or something like that. But I actually like to think of it generally with depth first search or recursion, because there is something innate about it that allows you to express a problem with respect to itself. So I think that's what I'm going to do. So basically we're going to have a helper function that, let's define what it does, right? This helper function for finding the tilt of a node and also the sum of all the sub nodes, right? So the second part is important so that we could do it all at the same time, because otherwise then things may get a little because then now this helper allows you to answer 2 questions at the same time, but those problems are related and they both have similar sub problems. And you can kind of do it. You could have also done it in you could also do it in 2 paths if you like, with 2 helper functions, one to get the sum, put it on the node, and one to get the tilt afterwards. But this is what I'm going to do. Maybe we'll name it get tilt and sum of node. So if node is none, what happens when node is none? Well, when node is none, the tilt of the node is 0 and the sum of the node is 0. So okay, so we can return that. Otherwise, we do the left tilt, left sum is equal to get tilt and sum of node dot left. Right tilt, right sum is equal to get tilt and sum of node to the right. And then now you could also, by the way, you can also, by the way, use a global variable like total tilt or something like that here. But I'm going to try to do it this way to show that you don't need to always have a global variable. So yeah, so now given these 2 things, how do we get, so what is the new thing, right? So we want to return, so the tilt, so we have to kind of be a little bit clear about this. This is finding the total tilt of a node and its children. I like to update the definition as we do, so that if I go back and I have a bug, I can figure out why, my assumptions have changed over time. And that is just left tilt plus right, left tilt plus right tilt plus the current tilt, right? What's the current tilt? Well, it's just the left sum minus right sum in absolute value. And then for the sum of this node, it is just left sum plus right sum plus node dot value, right? And that's pretty much it. So then we could get total tilt, sum, total because that's a keyword, is equal to that tilt and sum of root, and we just have to return the total tilt. And maybe this is left total tilt, maybe that's a little bit clearer. Yeah, so let's give it a go. Let's also put the other test cases in here. That's 2 and 3. Looks good. And the only thing that may be a little bit weird is maybe edge cases like 0, but no, that should be okay. So let's give it a go. Like 0 nodes or something like that. Looks good. Yeah, so what's the running time of this? This is linear time because we look at each node once with the recursion. In terms of space, it's recursion, so it's going to take the height of the tree, which is O of h, or linear in the worst case. So O of h slash O of n space and O of n time. Let me know what you think. Hit the like button, hit the subscribe button, join me on Discord, and I will see y'all tomorrow. Bye bye.